Welcome back everyone for a special edition of the Sky Tonight show, where we received a lot of questions and I'm here to answer all of your curiosities about the universe. It's Nicole again from the Lowman Planetarium, and this will be my final Sky Tonight show, at least for the summer, but I hope to be back in the fall working at the museum and again creating some more digital content for you all. So thank you to everyone who submitted a question for this. I'm very excited to learn more about what you'd like to know about the sky. And let's just jump right into those questions. So the first program that I've been using to do tours of the solar system where we take a look at the planets is UniView. And this is the software that we use in the Lowman Planetarium when you come to see our live Sky Tonight or Flight Through the Universe shows. Now this allows me to take a look from our viewpoint on Earth, as well as travel to other planets in the solar system, and even go all the way outside to the edges of the known universe. So I really liked using this to show some aspects of the different planets. And so here we've got Saturn, which brings us to the first question from the audience. Now someone was wondering about the hexagon shape on the top of Saturn near its north pole. So here you can see the six-sided figure right there. The question was, did scientists figure out why there is a hexagon on Saturn? And the answer is yes. They have a couple hypotheses as to what this shape is. Now, it was first discovered by NASA's Voyager flybys in 1980 and 81, but it was not confirmed until the spacecraft Cassini went and visited it around 2006. So scientists believe that it is a six-sided jet stream at the North Pole, and it flows eastward at 220 miles per hour following this outline of the shape. They also discovered that the points of the hexagon rotate around the center at the same rate that Saturn rotates on its axis. And so the main conclusion from this is there are shallow jets at the cloud level that help keep the shape of this hexagon there. And there are a couple more theories as to what creates this shape, but that is the most widely accepted one. So there are jet streams on the cloud layers that create this distinctive hexagon. So the other program that I've been using for these Sky Tonight videos is called Stellarium, and that is free for anyone to use and download. Just go to stellarium.org. Now this has been very useful for showing the constellations and stars and easy ways for finding them, since we've got these cardinal directions all along the bottom, and it's very easy just to select a star, and then I can put up the rest of the constellation as you've seen in the past couple weeks. So this has been very useful for, again, identifying those constellations and asterisms, and anyone can use it, so feel free to check it out on your own. So we also had a guest say that they noticed what looked like small stars moving at an alarming pace in several different directions across the sky. And I think that you're probably looking at satellites there, since they tend to have a pretty steady pace as they're moving across the nighttime sky, and there are many that you can see on a various night. So they can sometimes brighten or dim as they're moving. It just depends how the sun is hitting that satellite and bouncing off, so we can see it here. Now there are also a lot of Starlink satellites from SpaceX, which you can see as a line streaking across the sky. Now I just set the time to a little bit earlier in the evening, since the best time to see satellites is either right after sunset or just before sunrise, when the sun can reflect off them and then we'll be able to see it. I also wanted to point out one of the most famous satellites right here. There's actually the third brightest object in the nighttime sky, and that is the International Space Station, or the ISS. I'm going to start time here, and you can see how fast it moves across the sky. It will look like it's going very quickly, and you might not be able to see it for a very long time before it disappears below the horizon. Now the ISS circles Earth once every 90 minutes, so you'll be able to see it every hour and a half or so if it's visible in your location. And to find out if you're able to see it, you can even download an app from NASA that will tell you when it's going to be above your location. So again, those bright lights that you see streaking across the sky could definitely be satellites, might even be the ISS. Now this is set to normal time, so you can see how fast the ISS is moving. And we had another audience question that asked about a flash of light near the Big Dipper's ladle here. So you can see the asterism of the Big Dipper in the constellation Ursa Major, and if you saw a flash of light in that ladle, it might be the ISS. Now you probably also notice that I have the label up for the comet Neowise. And one of our other audience questions was, do comets shimmer? So first we have to talk about what a comet is. So it's basically a chunk of ice, rock, and dust that orbits the sun. So it has a heart or nucleus, which is an irregularly shaped spinning chunk of dirty ice. It has rock and dust particles on it. And when it moves toward the inner solar system, the heat from the sun causes ice near the surface to sublimate. So that means it goes directly from the solid state of matter to a gas. Now, when this happens, it releases ice particles and gas that disperse to form a bright, fuzzy cloud around the nucleus, which is called a coma. And it reaches that maximum size of the tail when it is closest to the sun. So that's what causes a glittery shimmer that we can see in the nighttime sky. Now, this comet is a hot topic right now since we can see it throughout July. Now, Neowise was first discovered on March 27, 2020 by NASA's Near-Earth Object Wide Field Infrared Survey Explorer. If you put that acronym together, that's how you spell Neowise. So it's a long-period comet with a near parabolic orbit, and that means its eccentricity is almost equal to 1. I believe it's 0.9991. Now, it is visible from the northern hemisphere in the evening sky. As you can see here, it's in the northwest region. It was closest to Earth on July 23rd, only 64 million miles from our planet, which seems very far, but compared to some other things in space, it's pretty close. However, it is getting dimmer, so you will need binoculars to spot it. And around this time of the month, it is appearing higher in the sky each night around the Big Dipper. So here we've got Ursa Major and the Big Dipper here. And you can find it around that location, even towards the end of July. So once you get your binoculars and you locate the Big Dipper in the northwest part of the sky, and you're going to look for Neowise, you should search for a fuzzy star with a bit of a tail. So I'm going to zoom in here and you can see what I mean with the tail part. Now again, it might be too dim to see this with your naked eye, but with a telescope you can see this tail shape here, part of the coma, and then the heart or the nucleus of the comet there. Of the month, which is the last option that you'll have to view it. Finally, we covered a lot of the summertime constellations in the show, but I wanted to give you a sneak peek of some of the constellations that you will see later this year. So we had an audience question about Orion, and that's one of my favorite constellations to talk about. It's very easily recognized by the 3 stars lined up in the center, which make up something called Orion's belt. And also it has 2 famous stars on the edges, one in the shoulder here, which is called Betelgeuse. And Betelgeuse is famous because it is about to go supernova. So it is approaching the end of its lifetime and will soon explode. Now, because it's so far away from us, again, it won't impact us at Earth at all, but we will be able to see it as this bright phenomenon in our nighttime sky. It's reddish orange in color, so very easy to identify, as opposed to some of the other stars in the constellation, which might be a little harder just because of their size and color. In the opposite corner of Orion is this blue-white star called Rigel. And I bring it up because blue-white color means it is the hottest kind of all stars. So again, we talked about this in a previous episode, but a star's color has to do with its temperature, and blue-white is the hottest of all. Getting cooler, we have white stars. Next is yellow, like our own sun. After that is orange, and finally the red-orange are going to be the coolest. But Rigel is at the opposite end of the spectrum, being one of the hotter stars. Now there are a lot of other interesting things in Orion, such as the Orion Nebula, but I'll save that for a later star show when we talk about some of the wintertime sky, or maybe even you can visit the Lowland Planetarium and see it in one of our live shows there. So that is all I have for the final Sky Tonight show with me. I hope you enjoyed learning about some of these stars and constellations and are able to use these facts to find them on your own. I'll be around in the museum if you ever want to stop by and ask more questions. Thank you so much for joining me on these Sky Tonight tours, and happy stargazing!